Every time you slow down your car, an incredible chain of mechanical and hydraulic events takes place in less than a second. In this animation, we'll follow that journey, from your foot pressing the brake pedal to the brake pads gripping the spinning brake disc. Everything begins with the brake pedal. When the driver presses the pedal, a mechanical force is created by the driver's foot. On its own, this force isn't strong enough to stop a vehicle traveling at high speed. Instead, the pedal acts like a lever, multiplying the driver's effort before transferring that force directly to the brake booster. The brake booster is the first major component in the braking system. Its job is simple but extremely important. It increases the force applied by the driver's foot before it reaches the hydraulic system. Inside the booster is a large diaphragm connected to the engine's vacuum supply. Vacuum is drawn through this nozzle, and it is spread to both sides of the booster. The right side receives vacuum through this passage, which is always open when no brakes are being applied, and this means that under normal conditions, vacuum exists on both sides of the diaphragm. But all changes when the brake pedal is pressed. A valve opens inside the booster. Atmospheric air enters the pressure side, while vacuum remains on the other. The difference in pressure pushes the diaphragm forward with considerable force, hence supporting the driver's effort. The boosted force is then transferred directly into the master cylinder. The master cylinder converts mechanical force into hydraulic pressure. Inside are pistons sealed with rubber cups and surrounded by brake fluid. As the brake booster pushes the piston forward, the piston compresses the brake fluid trapped inside the cylinder. According to Pascal's principle, pressure applied to a confined liquid is transmitted equally in every direction. This means the pressure generated inside the master cylinder instantly travels throughout the entire brake system. Once pressure is created, the brake fluid begins traveling through the brake lines. This hydraulic pressure finally reaches the brake calipers. This is the brake caliper. Inside every brake caliper are one or more pistons. Hydraulic pressure enters the caliper behind these pistons. It pushes directly against the piston surfaces. The amount of movement is very small, usually only a few millimeters, but it produces a tremendous clamping force. At this point, the hydraulic energy has now been converted back into mechanical force. The brake pads are made from specially engineered friction materials designed to withstand extremely high temperatures. During heavy braking, the brake discs can become several hundred degrees Celsius. Ventilated brake discs help cool the system by allowing air to flow through internal cooling channels, preventing excessive heat buildup and maintaining braking performance. The harder the driver presses the brake pedal, the greater the hydraulic pressure becomes.